Okay, class, we're back and we're doing the last part of acid base. Up to now, I've explained to you kind of what pH is, acids are, bases are, kind of the normal, the physiological. But I also mentioned that the abnormal, if the person had the improper pH in the arterial blood, the abnormal could be placed into 4 categories. Whether it's a metabolic, if the blood is too acidic, whether it's a metabolic acidosis, respiratory acidosis, metabolic alkalosis, or respiratory alkalosis. So it would fall under one of those categories. Now, there are many reasons underneath those categories. But this, again, is what we call a workup. Remember what we said? If a condition had multiple etiologies, you do a workup. So this is really a modified workup. Okay, to understand this, I think you can do a lot of this yourself. I have a document that you can look at in the ANP2 section. It's an MS Word document. It's a Word document, and it's going to be called Acid-Base Disturbances. So if you use this document in conjunction with the PowerPoint, which is acid-base PowerPoint, I think you'll be able to understand this quite well. Don't forget your tutors can help you, and also I can help you. All right? So let's just go through it very briefly. I think you can do a lot of this on your own. All right. How do you determine the type of acid-base disturbance? First of all, you look at the pH of the person's arterial blood. See, here would be an arterial blood gas report. There's the pH right there. What do you look for? Is it out of normal range or in normal range? If within normal range, in most cases, the person does not have an acid-base problem. Sometimes they do, and the reason is in normal range is for strong compensation for a problem. In other words, a respiratory problem could be compensated almost fully by metabolic compensation, and we'll see that. But most of the time, you will never get full compensation. Let me say that again. Most of the time, if one thing goes out of whack, you will never get full compensation. You'll generally get partial compensation. Okay? All right. So let's go further here and just kind of walk through this. And again, you can look at it, read it on your own. Okay, so if the pH is out of range, is it acidic or basic? Remember, normal pH is between 7.35 and 7.45 in the blood. Okay. If it is acidic, less than the 7.35, is it a respiratory problem or metabolic problem? If the pH is alkalotic, greater than 7.5, then it's a respiratory or metabolic problem. Okay? How do you determine that? Look at the PaCO2 and the HCO3 minus. The PaCO2, which they just say PCO2 because they already know it's arterial, and the HCO3. That's it here. So that's the things you're looking at. See right here, I got them listed here. So we really are looking at this. We don't even look at the O2. This, and this. What are we saying? We're looking at this. Put that in red. This. Put that in red. And this. And that's the values you'll look at to make that determination. Okay? So let's go further. In a respiratory, so now we're saying, look at the pH and all this right here, right? Okay, now we're going into the various aspects. In a respiratory acidosis, now what does that mean? The pH is too low. That's acidic. The PaCO2 is elevated. That's the problem. Okay, too much CO2. This elevation causes an increase in the amount of carbonic acid formed. If it is a respiratory acidotic cause, the HCO3 is generally elevated. if the kidneys are trying to help. They will decrease the urinating of base. So you got an increase in respiratory acid, that's the culprit, but the kidneys are trying to hold on to more base to neutralize it if they're trying to help you. The alkaline bicarbonate is trying to neutralize some of the fixed acids. So you can't really neutralize the CO2 bases, so you're neutralizing the fixed acids. Remember, we had volatile acids. That was the one created from the carbonic, and fixed would be like lactic, hydrochloric, and other acids in your body. So the bicarb then is trying to neutralize some of the fixed acids to drop that value to compensate for the increase in the volatile acids. So study this heavily. As an example of this is an asthmatic attack, or COPD, or something that suffocates. You cannot blow off enough CO2. So here's an example right here. So in other words, in that particular situation, you see what's happening is you're not airway obstruction, anesthesia, things of this nature, COPD, acute respiratory distress syndrome, pulmonary embolus. There we are. All of this could cause that particular aspect. Now, what do you see here real quick? You see that the pH is low. The PaCO2 is high because that's the cause. And the bicarb is trying to be elevated to compensate. It's being held on to. Kidneys aren't peeing it out, and this is trying to neutralize the fixed acid. So when you look at the Henderson-Hasselbalch, that's what you're seeing. All right, let's move to the next one. You can read this. In a metabolic acidosis, again, you're acidic. So the pH is showing an acidic aspect. There's some increase in the amount of fixed acids. That's the cause for the acidosis. It's not the lungs. The PaCO2, is decreased. Why? Because the person is breathing hard and heavy to try to reduce the carbonic, the volatile acid, to compensate for the increase in fixed acids. Okay? You see what I'm saying? The bicarb is trying to, just the PaCO2, the bicarb is trying to hold on and nullify some of these acids, these fixed acids. An example of that is diabetic ketoacidosis. Look it up online. Now, the pH is low. Okay. The bicarb is low. But it's low because it's trying to neutralize what? Fixed acids. And the PaCO2 is low because you're breathing hard and heavy to reduce volatile acid to compensate for that increase in the fixed acid. Okay? So when you look at that metabolic acidosis, see what we got? See, here would be like nausea, vomiting, diarrhea, you lose acid, this type of thing there. Okay? You lose base in diarrhea, a lot of base. Diabetic ketoacidosis, like we said. Okay? Severe diarrhea. You lose base. Both ends of the gut. By the way, both ends of your gut are high in potassium. So if you have a lot of diarrhea, you're also going to lose potassium. You're going to start getting crampy muscles and everything. All right? All right, let's go further. You can read on it. In respiratory alkalosis. Now let's think about that. Respiratory alkalosis. First thing you looked at the pH. Are you alkalotic? This is kind of alkalotic right there. See that? That's above 7.45. Okay. Now the compensated is not. Okay. But anyway, the PaCO2 is decreased. See, that's the culprit. It's not enough volatile acid, so you're alkalotic. Thus, the level of volatile acid is too low in the blood. As a compensatory action, the kidneys will try to urinate out more bicarb, try to drop base to compensate for not having enough of this acid, and they may try to hold on to more fixed acids. Bottom line, the blood bicarbonate level goes down. The kidney's effort to urinate out base and hold on to assisting pH close to normal range. Example of this would be hyperventilation. It could be caused by anxiety and various things. Let's look at it. So here we are in a respiratory alkalosis. Hyperventilation, anxiety could have done it. Okay? So when you look at it real quickly, the pH is high because it's alkalotic. The PaCO2 is decreased because you're breathing too hard. And the bicarb tries to decrease so that to compensate. Let's go to the next one and the last one. In a metabolic alkalosis, the fixed S are low. This is the cause for it. Okay, that's the cause. So you're still alkalotic. Okay, let's go here. So this could be caused by overconsumption of basic substances or kidney problem in which too much acid is urinated out or the base is retained. It can also be caused by severe vomiting, remember what I said, and diuretics, various things like that. Anyway, here it is here. All right, now what do you have? In this case, that you have a metabolic alkalosis, right? And the PaCO2 is elevated to try to compensate. So you're breathing less to try to compensate. Try to raise volatile acid to compensate. You see what I'm saying? For losing too much acid. Okay? So this would be what you would see on that Henderson-Hasselbalch. Now read on this. So look at the PowerPoints. Look at the video I just did. Look at the PowerPoints. Look at the video. Look at the acid-base disturbances. Okay. Look at my acid-base PowerPoint. See, I have the acid-base disturbance is an MS Word document. The acid-base PowerPoint is in PowerPoint section. So if you look at all of that, because acid-base is a big issue in the clinical situation, whether it be in medicine or nursing. So hopefully this will kind of help you. All right. Thank you there.